Hello there, Mr. Sutton here with the AB Calculus 310 Extra Practice number 4 solutions on derivatives of exponential functions. To find the derivative on this one, we have x to a constant. So that means we're actually going to use the power rule, not any kind of exponential rule. So we're going to multiply by the exponent. The exponent is 1 plus radical 2. So we have a factor of 1 plus radical 2 out in front. And then we're going to multiply that by x to the whatever the exponent is minus 1. Well, 1 plus radical 2 minus 1 is just going to be radical 2. So this is going to be x to the radical 2. For this one, I need to use the chain rule to take the derivative. So I have 9 to the something as the outer rule. That's going to be 9 to the something times ln of 9, ln of the base. And now the derivative of the something, derivative of negative x, is going to be negative 1. To take the derivative on this problem, I'm going to need not 1, but 2 product rules. So let's use the box and ribbon on the first one here. We have x squared and e to the x. And the derivatives of those are 2x and e to the x. Using the ribbon to multiply things out, that's going to be 2x e to the x. Plus x squared e to the x. And now we have to take the derivative of negative x e to the x. So I'm going to use another product rule on that one. So a second box and ribbon here. And for my first factor, I'm going to use negative x. So I'm going to account for that negative sign inside the box here. And then I also have an e to the x factor for that one as well. Derivatives, we've got negative 1 and e to the x. Using the ribbon to multiply that out, this is going to be negative e to the x. And then we're going to have negative x e to the x. On this problem, I'm going to have to use a couple chain rules. So for this first term, e to the 7x, derivative of that, we're doing e to the something. So the derivative of e to the something is e to the something, e to the 7x. But now we have to multiply by the derivative of 7x, which is 7. For this next one, the outer rule is 4 to the something. Derivative of that is going to be 4 to the something times ln of 4. But now I have to multiply by the derivative of the something, the derivative of 5x squared, which is 10x. On this one, I'm taking the derivative of e to the negative 5x. That's a chain rule. Outer function is e to the something, so the derivative of the outer function is e to the something. But now we have to multiply by derivative of the something. Derivative of negative 5x is going to be negative 5. For this problem, trying to take the derivative of pi to the x times tan of x. So there's a few things involved in this one. First off, we have a chain rule. We have the derivative of pi to the something as the outer function. So that's going to be pi to the something times the ln of pi, because pi is a constant. But now we have to multiply by the derivative of x times tan of x. And for that, we're going to need the product rule. So let me get the box and ribbon out here. I've got x, I've got tan of x. Derivatives are going to be 1 and secant squared of x. And now multiplying that out using the ribbon, I've got 1 tan of x, and this is all going to have to go into parentheses now. So tan of x plus x secant squared of x. On this problem, I'm trying to take the derivative of this quotient. So I'm going to have to use the quotient rule on this one. U prime v minus uv prime all over v squared. And to do that, let me use the box and ribbon to help organize things, because there's a lot going on in this one. The numerator, that's e to the x cubed. And we have the denominator, all this stuff to the 5th power. So both of these are going to require the use of the chain rule. For e to the x cubed, I've got the derivative of the outer function, which is e to the something. So derivative of e to the something is e to the something, e to the x cubed, times now we have the derivative of x cubed, which is 3x squared. And over here, I have something to the 5th. That's the outer function. So the derivative of that is going to be 5 times the something to the 4th. But now I have to multiply by the derivative of something. Derivative of 12x cubed. Or the derivative is 12x cubed, I should say. Okay, so now let me actually put it all together in a big fraction. So we've got e to the x cubed 3x squared times this 5th power parentheses minus, so we're doing the other direction on the ribbon now, so minus e to the x cubed times all of this stuff in the lower right. And I think I got everything there. Yep. And now we have to divide that by v squared. So that's this fifth power parentheses squared. To take the derivative of this function, I'm going to have to use the chain rule. My outermost function is e to the something. Derivative of that is going to be e to the something. And I'm just going to rewrite this as the 1/4 power instead of fourth root, just to make my next step a little bit easier. Because for my next step, I have to take the derivative of the something here. So that's going to be using my power rule. I've got basically something to the 1/4. Derivative of that is going to be 1/4 times the something to the negative 3/4. If I do 1/4 minus 1 minus 4/4. And now finally I take the derivative of the something, the innermost something. Derivative of 3x squared plus 4 is just going to be 6x. To find the derivative of this one, I'm going to have to use the chain rule. My outer function, I've got cosecant of something. Derivative of that is going to be negative cosecant of something cotan of the something. And the something is just this e to the 4x cubed. Now I have to take the derivative of e to the 4x cubed and multiply by that. So that itself is its own chain rule. Our outer function there is e to the something. Derivative of e to the something is just the e to the something. But now we have to take the derivative of the innermost something, the 4x cubed, and that is going to be 12x squared. For this problem, I'm trying to take the derivative of square root of e to the 3x squared. Now this is going to be a chain rule one way or another, but it could be a little bit less of a chain rule if you're a little bit clever with your exponents. This is really e to the 3x squared to the 1/2 power, so I can actually multiply those exponents to rewrite this as e to the 3/2 x squared. And now I really just have like a two-step chain rule. So my outer rule this time, I've got e to the something. Derivative of that is e to the something. But now I have to multiply by the derivative of the exponent here. So that's going to use the power rule. We have 2 times 3/2, which is just 3, x to the first.